So, hello and welcome to a new lecture on statistics, where this time we are going to introduce the formal concept of variance. So, what is a variance? That's actually the question of today's lecture, and in order to get started, we will first going to introduce the formal definition of what the variance actually is. So, the variance basically of some random variable x is basically some kind of expected value. So the expected value was introduced in the previous lecture. We are going to use this result here, and we are going to provide now the formal definition of what the variance actually is. And as I said, it's some kind of expected value of some very particular random variable. So basically it's the random variable x minus mu, and mu is actually the result, the outcome of the expected value of some random experiment, to the power 2, so squared. And using the definition of the expected value from the previous lecture, we can actually then write down this in a more illustrative way. So basically it's the sum going from some value k1 to some value m of the new random variable x minus mu squared. So basically it's then the different results x of k of the random variables minus this parameter mu, which is basically then the expected value, to the power 2, multiplied by the respective probabilities of the initial random variable x. So x equals x of k. Where here we remind that mu actually is the expected value of the random experiment. So it's the expected value of all the random variables that are associated to the sample space of the random experiment. And we also have to indicate that basically the random variable x belongs to the set of values x1 going up to the value xn. So n is the same n as here. So with this, we are now ready to work out a precise example, and we are going to use the example again that we already introduced in some of the previous lectures, which is basically the one of the flip of a coin 2 times. So we saw from previous lectures that basically we have a sample space that is associated to this particular random experiment and is composed by 4 different elements. So heads, tails, tails, heads, or 2 times tails. And as an event, we introduced actually the question of how many times do we obtain tails when we flip a coin 2 times. And basically, what we obtained is x equals 0 for 0 time tails, the random variable x equals 1 for 1 time tails, x equals 2 for 2 time tails. And here we see that actually in this precise example, the random variable x belongs to the set going from 0 to 2. So basically, this has to be is related to the expression here, which is a more general formulation of the same thing. The associated probabilities are basically provided here in the table. So we have a probability x equals 0 of 1/4, probability of x equals 1 2/4, and probability of x equals 2 is 1/4. So before we will write down now and work out the result of this of the variance in this precise example, we should try to intuitively understand what actually the variance will tell us. So we see from the definition here that the variance basically is some sum of measures. So basically it's a sum of the random variables, and it tells us how the different random variables are actually distributed around the expected value mu, which is the result of the expected value. So basically the variance tells us if the different outcomes of some random experiment are widely distributed around some expected value, or the expected value of this random experiment, or very closely and sharply peaked around the expected value. So with this, we are now ready to work out this precise example, and we can actually then use the results in the table. So what is the variance here in this particular case? So we have to sum up all the different random variables multiplied by their corresponding probabilities. So in this case, we have as first random variable x1, which in this case is 0. So basically we have 0 minus the result of the expected value, and for this precise example we saw in the previous lecture that the result is 1. So we're going to subtract 1 here to the power squared times the associated probability, which is 1/4. So as it is a sum, we have to sum then to add the next element, which in this case is then 1. So basically 1 for x2 here. So it's 1 minus the expected value of this precise example, which is 1. Then the square, of course, times the corresponding probability, which is 2/4 or 1/2, plus the last element, the last random variable, which is 2, minus the associated expected value of this random experiment, which was 1, to the power 2, times the associated probability, which is in this case 1/4. So let's work out this result. So basically here we have 1 to the power squared, which is 1, times 1/4, plus 1 minus 1 is 0. So 0 times 2/4, 0 squared is still 0, and times 2/4, 0. So basically we have here 0 times 2/4, plus 2 minus 1, which is 1, multiplied by 1/4. And from this we can easily see that we have 1/4 plus 0 plus 1/4, which is 1/2. So with this result now we are trying to understand this result in this precise example, and in order to do so we are going to use the probability mass function that was introduced in the previous lecture. And we basically see that we have the 3 random variables here, 0, 1 and 2, with their corresponding probabilities, 1/4 and 2/4. And we see that in general we expect the result being 1, so it has the highest probability. And what does this 1/2 tells us in the end? Well, it basically tells us, as I already said, the variance tells us how the different outcomes of a random experiment are distributed around the expected value. So basically this 1/2 tells us that 1/2 of the results, 1/2, so 0 is on the left of the expected value, and 1/2 of the other variables, random variables, are on the right of the expected value 1. So basically the variance is a parameter that tells us how the different random variables are distributed around the expected value. So I hope this video was of some use for you. If you like more content like this, then please like my video and subscribe to my channel. See you in the next video.